I'm recording a video to solve the problem 943, 9.43. I'll directly dive into this problem. Okay, no time to waste. So it is a voltage, VT, VG over here, and resistor, inductor, capacitor, and here's A and B, the 400 nanofarads. And keep in mind, the impedance of the capacitor is 1 over j omega c, which is minus j over omega c. So for this capacitance value, is converted to minus 500 j eventually for the impedance. And this is 50 millihenry. And this becomes 250 j. And this is a 200 ohm resistor. And it's also 50 millihenry, so which is 250 j as well. And VG, so VG is given, which is 22.36 cosine 5000 T plus 26.565 degrees. Okay, and this can be written as 22.36 angle of 26.565, right? So this is basically a voltage divider. It's trying to get the VTH, which is a open circuit terminal voltage, which is just basically VAB in this entire circuit. And you just have to find out the equivalent resistance over here, and it becomes this impedance in series with this impedance. So this becomes a very simple voltage divider problem to try to get the voltage over here, right? So first we have to find out the impedance, equivalent impedance of this network. So let's do Z equivalent equals. So this is 200 plus 250J, which is the impedance over here. In parallel with that guy, it's 200 plus 250J. Okay, in parallel with what? In parallel with this. And this is 250J plus 200 minus 200 plus negative 500J, and then do a multiplication on the top. Right? So let's find out. Let's divide 100 on both sides, on top and bottom. So we're getting 200 plus 250J and minus, we're doing, 100, sorry, let's do 100 first. 5J, and here 100 becomes 2 minus 2.5J. Okay, so now you have multiple options. You can times 2 plus 2.5J on top and bottom to cancel this, to convert this to a constant, or you can just use a online calculator, or your calculator probably will be able to do the job. So let's expand this first. So we're getting minus 1000J plus 1250. Okay, so combine these two, and then divided by 2 minus 2.5J. So I have a calculator that I posted to my website already. So when you are working on the problem, if you don't want to use your calculator, you can use this one, no problem. Okay, so we're here. Because this is if you look at this one, this is a rectangular form, right? Let's do a rectangular form to polar conversion. This is the real part. This is imaginary part. Convert. So we got on the top, it becomes 1600.78, and the angle is minus 38.66. Okay, for the bottom, it's 2 for the real part, and minus 2.5 for the imaginary part. We're getting 3.2. Angle is minus 51.34. Okay, And then do a division. Division here, subtraction here. Grab a calculator. It's 1600.7a divided by 3.2, which is 500.24, and the angle is this subtract this, okay, which is basically 51, because the minus sign is getting canceled. You are getting this subtract this is basically 51.34 minus this, right? So 51.34 minus 38.66, and that's 12.68 degrees. So eventually, the equivalent impedance becomes this, and now we plug it back in, plug it back in. The use the voltage divider series is equivalent um, resistance, and 250J only has a component on the imaginary part, so it's basically 90 degrees, and the amplitude is also 250. So you can directly write down 250 90 degrees for this guy. Okay, so eventually, the using the voltage divider theory, you are getting VAB equals VG, what VG times this guy, which is 500.24, 12.68 divided by 250 90 degrees plus 500.24, 12.68. Okay, this is what you got. And since we know that VG is this, so we are having 22.36, 265.565 times 500.24, 12.68 divided by 250, 90 plus 500.24, 12.68. So if you can calculate this, eventually that will be the final answer for this problem. Okay, let's verify it. Let's verify it really quick. I can still use a calculator. So for the top, amplitude or magnitude times magnitude, and the angle should be added together. So let's find out. Use this calculator. So it's 22.36 times 500.24. On the top is 11185.37, and the angle is 26.565 plus 12.68. That's 39.245. Okay. For the bottom, it's a addition, summation. So, it's better to use a calculator. The calculator has a phasor math. Okay. So for the first one, we have 250 for the magnitude and 90 degree for the angle. And for the second one, we have 500.24 for the magnitude and 12.68 for the angle. And then you choose V1 plus sum V2 and run this. You are getting 606.34. Angle is 36.39 or 40, let's say. Okay, so do a division here and subtraction here. 1185.37 divided by 606.34. It's about 18.45. Angle is 39.245 minus 36.40. That's 2.845. Okay, so this is how you got the answer by using this complex number method.